All right, trig applications. So when we're looking at trig applications, all we're doing is applying everything that we've learned so far to a real life situation. So with this, we've got an equation. We can find our amplitude quite easily. Our amplitude here is 4. Our vertical translation, again, pretty easy. It's at the end there. It's 5.4 that we've gone up. Even our phase shift, it's nice and easy to find. It's right in the middle there. We're going right 8. The only thing that we actually need to take some time to do is find out what our period is. Now remember, the period equals 2 pi divided by k. So then that means our period here is 2 pi divided by pi by 6, which is 2 pi times 6 over pi, which is 12. Okay, 2 pi times 6 is 12 pi over pi, and then the pi's cancel out. So we get 12. With all of this information, we can kind of put everything that we need on the graph. Okay, so if we're looking at this, if we're starting at 5.4, that kind of should be the middle of your graph, because that is our vertical translation. Okay, so we've got 5.4. We're going to have our dotted line there. That's going to be where the graph rotates around. That's pretty straight enough. If our amplitude is 4, that means that we're going to go up 4 and down 4 from that point to get our max and our min. So that's going to give us 9.4 here, and then down 4 would be 1.4. So we've got our max and our min. Now our starting point was at 8, and it's a sine graph, so that means we're going to be at time 8, and if it's a sine graph, we're going to be right in the middle there. Okay, our period was 12, so 8 plus 12 is going to be 20. We're going to be right back here in the middle. That's one period. Now remember, I said you can divide that in half. That will be a middle point, because that's going to be halfway through a sine graph. Cut this in half, we're going to have a max and a minimum. Now if I cut that in half from 8 to 20, well, we've got 12 there, so half of that is 6. So we're going to go to 14. 8 plus 6 is 14. If I cut that in half, 6 divided by 2 is 3, so we're going to have 8 plus 3, we're going to have 11. So really, every 3 squares horizontally, we're going to have a value. Okay, and that's going to help us answer another question here, because we can go back from 8 to 5, we'd have a minimum, and then back from 5 to 2, and we'd be back up at our value there, and then -1 would be our next value, so we don't have to include that. Going the other way, we're just going to add one more value. We're going to get to 23, and that would be a maximum. And now I can kind of draw my graph. So it's going to look something like this. Okay, and again, it's a sketch, but that's what it's going to look like. It says sketch it over a 24-hour interval. Our 24th hour would be kind of where my arrow is, so we've got it. The next value, I can actually just take it right off of my graph, because I've got a nice labeled graph. All the values are spread out, my scale is really good, I've got all of my y, all of my x. My x is time in hours, and it's hours from 0, which would be hours from midnight on a day. Okay, my scale over here, I believe is, what do we got going on here? Yeah, depth of the water, and it's in meters. So this is depth in meters. All right, so it says what's the maximum depth and what time does it occur at? Well, the first one occurs at 11. That's a max. The next one occurs at 23. That's a max. So it actually occurs at 11 o'clock in the morning. So determine the maximum depth. The maximum depth we found from the amplitude plus the vertical translation. So max depth is 9.4 meters, and it occurs at 11 a.m. and 11 p.m. 23 minus 12 would give us the p.m. times. Or you can learn a 24-hour clock, but 23 is 11 p.m. Okay, now the important thing about the next question is that your calculator is in radians. Okay, so when I'm looking at 6:30, this is where a lot of people are going to mess up. 6:30, and that should just be a.m. 6:30 a.m. would give me an x value. Is it x or t? Give me a t value, excuse me, of 6.5. Because there's 30 minutes in an hour, so I'd have to do 30 divided by, 60 minutes an hour. I'd have to do 30 divided by 60 to get 6.5. At 7:30 p.m., well, 7 hours after noon would be 19. And again, we're going to have 0.5. Okay, and now I just need to sub this into my formula. I'm going to let you do that on your own. I want to see what you're going to get. I've got the answers on the board in the class that you can check tomorrow. But you need to have your calculators in radians or you will get the question wrong. Looking at the next one, a Ferris wheel with a 10-meter radius rotates once every 30 seconds. Passengers get on at the lowest point, which is 1 meter. All right, so first thing we do, we're going to start at 1 meter because that's where they get on. Time 0. When you get on, no time's passed. It says it rotates once every 30 seconds. Well, that means I'm going to have a point way down here where I get back down to 0 because it rotated all the way around. It says my radius is 10. Now, people are going to get confused a little bit here, but if your radius is 10, it's got to go up 1 radius to get back to the middle, and then go up another radius to get to the top. So that's going to be 11 meters, and that's going to be 21 meters. So now we've got our minimum, our center line, and our maximum. Okay? We know that halfway between is when we're going to get to the max. So we're going to go up, come back down. Okay? Throw an arrow on the end. Maximum. Well, this value is going to be halfway between these two, okay, which is 7.5. Same thing over here, halfway between. It's going to be 15 plus 7.5, so 22.5. Or 15 plus 30 divided by 2, which is 22.5. So that's going to be that value. Okay, that's the first cycle. It says sketch a graph that's gone through the first 2 cycles. So all we're doing is getting to there. I'll just extend that line out. That's going to be 60. This is going to be 45. This is going to be 37.5. And this would be, 52.5. There's my first cycle. Not great, but my points are all there. 2 cycles. Write an equation to express the height with a sine curve as a function of time. Okay, a sine curve, I'm probably going to start with a positive sine value. So I'm going to start with the point right here, the first value that gets to the middle of the graph. Okay, so what that means is my phase shift is 7.5. So we've got 7.5 right. My midpoint of my graph is going to tell me my vertical translation. So we're plus 11. My radius is the amplitude, which is equal to 10. And my period is 30. This is what we're going to need to figure out here. We need to figure out our k value. And remember, period is 2 pi over k. So we've got 30 equals 2 pi over k. Our pi and our 30 are going to switch, and we're going to get k equals pi by 15. So now our sine function is going to be f at x equals our amplitude of 10 sine square bracket, our k value, which we just found, x minus our phase shift, which was 7.5. Close all my brackets, plus 11, which was my vertical translation. Okay, the next question asks, calculate the time, or sorry, the height after 9 seconds, you're going to just be subbing in for your x value or your t value for 9 seconds, and it's going to give you your height. I'm going to let you do that one on your own. I'm going to help you with the last one here. Okay, because the last one's a little bit difficult. It says, at what times will the Ferris wheel be above 18 meters or higher? Okay, so when will it be 18 meters or higher? We're just going to look at the first cycle for this. Okay, so I'm going to just sketch that graph out again. So we've got something like this, where we've got 11 right in the middle. This is 0. This is, we'll call this spot right here 30. That makes that 15. Okay? 18 meters or higher is going to be here, but it's also going to be here. So what we need to recognize is that these are equal distance to that midpoint. Because when we sub into our formula, it's only going to give us one value. Okay, this is like when you have a value in 2 separate quadrants. When you have it in 1 and you have it in 2 for sine. So we need to account for both of these values. So if we look at our sine formula, we've got f at x, this is the formula we just had, equals 10 sine pi by 15 x minus 7.5 plus 11. Now it says, when will it be 18 meters or higher? So our f at x is our 18 meters, because x is actually the time. So we're going to have 18 equals all of this stuff. All right, x minus 7.5 plus 11. Well, what that's going to leave me is I'm going to bring the 11 over and divide by 10. So 18 minus 11 is 7. 7 divided by 10 is 0.7. Then I'm going to write this in a line here just so you can see what's going on. I know I've switched colors, but I did that for a reason so that it was nice and clear for you. Now the way I get sine over to the other side is by sine inversing. So I'm going to sine inverse just the 0.7. So sine inverse of 0.7. Sine inverse of 0.7 is going to give me an angle. I'm going to have pi by 15 x minus 7.5. After I get my angle there, I'm going to multiply it by 15, divide by pi, and add 7.5. When I get all of that, I'm going to get x is equal to 11.2. Okay, so I found my x value. I found 11.2 is one of the values. That's 11.2. That's going to go right up to there, which would meet right there, 18 meters. But what I need to realize is that this distance is the same as this distance. So 15 minus 11.2 would be 3.8. So my other value is going to be 15 plus 3.8. So x also, or x equals 15 plus 3.8, which is 18.8. Now with that, we can say, therefore, it will be higher between, oh, those aren't meters, those are seconds, Mr. Shaw. Sorry, guys. Seconds. Between 11.2 seconds and 18.8 seconds. Okay, so you got to be careful with questions like that.